So we're going to practice converting hydrogen ion concentration into pH, or vice versa, hydrogen ion concentration into hydroxide ion concentration. And just as an intro to that, keep in mind this is something we talked about in class, but if you know the hydrogen ion concentration, you can convert it to pH using the equation pH equals negative log of H plus, or you can convert it back using the hydrogen ion concentration equals 10 to the negative pH. So once you know one of these, you can calculate the other one. You also can convert hydrogen ion concentration into hydroxide ion concentration, or vice versa, using the equation Kw equals H plus times OH minus. Kw is on the yellow sheet, but it is equal to 1 times 10 to the minus 14 at 25 degrees Celsius. You can also calculate pOH, which is the fourth and final value that we're going to talk about, using the equation pOH equals negative log of the hydroxide ion concentration, or you can convert the other way, the same as above with hydrogen ion concentration, that the hydroxide ion concentration equals 10 to the negative pOH. Finally, the last equation that you can use is that pH plus pOH, the sum of those two numbers should equal 14 for a given solution. So in summary, once you know one of these values, any of the four, you can calculate the other three using this set of equations. By the time you get to the fourth one, if you're actually calculating all four, by the time you get to the last one, there are going to be two ways to solve the answer. We'll talk about that when we do these practice problems. We did some of these in class together. We're going to do them all again. Some of these we didn't do together, but we did the first row and the third row. But we're going to repeat it here in case you need to see it again. But you can always fast forward if you don't want to see it. So this first box, hydroxide ion concentration, we can calculate from hydrogen ion concentration using the equation Kw equals the product of those two. So you just plug the numbers in, and you get that the hydroxide ion concentration is 8.3 times 10 to the minus 12. I'm going to put that in the box. The second box, pH, we're going to calculate from hydrogen ion concentration. It's the negative log of 1.2 times 10 to the minus 3, which is 2.92. Sig fig wise, we're going to write 2.92 in the box. Remember that the significant figures for logarithm, you keep the same number of digits after the decimal as the total number in the number that you're given. So 1.2 times 10 to the minus 3 has 2 sig figs, which means 2.92 has 2 digits after the decimal. pOH is the negative log of the hydroxide ion concentration, or 14 minus the pH, which gives you 14 minus 2.92, which is 11.08. Another way to do this problem is that pOH is the negative log of the hydroxide ion concentration, which is here, 8.3 times 10 to the minus 12. Solving it that way should give you the same exact answer. And the same sig figs. So row 2, we're going to start by calculating hydrogen ion concentration from hydroxide using the Kw as the product of those two. Plug the numbers in, you get 2.3 times 10 to the minus 10 molar. pH is the negative log of that number. I put in the unrounded number here because it might slightly change my answer to have the rounded number. So whenever you're doing a calculation, you should use the unrounded number in your calculation. Let me know if that doesn't make sense, but 2.3 might change my answer slightly, so I'm not going to change it. So 9.63. And then pOH, we can solve one of two ways. It's either the negative log of the hydroxide ion concentration, 4.37, or it is 14 minus 9.63. There's always sort of two ways to do the last one. That should still give you 4.37. It shouldn't matter. But you can always use that as a check. Yep, got the same answer. That's good. I feel good. Now we're going to erase that and do row 3. We start with 5.42. We did this one in class, actually. We're going to start with the hydrogen ion concentration, which should be 10 to the negative 5.42, which is 3.8 times 10 to the minus 6. Then we can calculate the hydroxide ion concentration from that number, knowing that the product of those two numbers is Kw. Plug in the numbers. Use again the unrounded number here. I rounded it here, 3.8, but the actual number was 3.80189. And then you plug those in and you get that the hydroxide ion concentration is 2.6 times 10 to the minus 9. Again, I don't want to get rounding errors in my answer. That's why I use the unrounded number. POH is 14 minus the pH, which is 8.58. Or we could have used the hydroxide ion concentration and solved it that way. That should give us the same number, 8.58. It would have been 10 to the negative 2.6 times 10 to the minus 9 should also give you 8.58. I'm sorry, the negative log of 2.6 times 10 to the minus 9 should still give you 8.58. Now this box here, hydrogen ion concentration, we can't actually calculate that directly from POH. This is the only calculation you can't do directly from POH to hydrogen ion. So we're going to start by calculating pH from POH. I'm going to do this box instead. So that's going to be 14 minus 4.39. That's going to give me 9.61. I'm going to put that in the box. Now I can calculate hydrogen ion concentration because that's going to be 10 to the negative 9.61, sorry, and that's going to give me 2.4 times 10 to the minus 10, or 2.5 times 10 to the minus 10. The reason is because the answer is 2.45, and it depends on how you round 5. If you round it up or you round to the even number, either way, that's acceptable. The last calculation here is hydroxide ion concentration. You can either do 10 to the negative POH, 10 to the negative 4.39, which gives me 4.1 times 10 to the minus 5. Or I could have calculated it from the hydrogen ion concentration. It would be Kw divided by this 2.4547 times 10 to the minus 10 number should still give you the same value here, 4.1 times 10 to the minus 5 molar.